Welcome to the Transum podcast, a monthly roundup of the new features on the transum.org website, providing mathematical puzzles, games, learning activities, and the ever-popular mathematics lesson starter of the day. Here's your host, John Tranter.
It's December, and welcome to podcast number 121 for December 2024. I wonder if I'll be the very first to wish you a Merry Christmas and a Happy New Year. Well, with that festive thought in mind, here is the puzzle of the month.
While Santa was busy delivering presents at Tran Towers, Prancer, one of his reindeer, went for a stroll to the base of Crimble Hill. Prancer then walked up the hill to enjoy the view of Twinkle Town from the top. After taking in the view, Prancer retraced his steps back to the towers. The round trip took 6 hours. Prancer averaged 4 kilometers per hour on level ground, 3 kilometers per hour walking uphill, and 6 kilometers per hour downhill. How far did Prancer walk?
That is the puzzle of the month for you to contemplate. You'll need to wear your thinking cap and really concentrate. And if you think you've solved it and your answer is correct, then send me an email of your thoughts and solution. I'd be very pleased to hear from you. So while you think about that, here are some of the key resources added to the Transum website during this last month. Christmas Tree Lightsome challenges pupils to choose the colours of the lights on a Christmas tree so that the pattern is balanced. I've left that deliberately ambiguous, so it could mean symmetrical, but it's up to your artistic feeling at the time, I guess. So you have to choose the colours of the lights on the tree while ensuring that the numbers on the lights add up to the randomly generated targets. So I guess everyone in a class would undoubtedly come up with a different pattern after a suitable mental maths workout with a festive theme. What more could you ask for? I made a Christmas video. Now, no comments about my singing, please, but this video is called Christmas Puzzles, and it's a festive collection of 12 engaging mathematical puzzles, most of which feature their own interactive webpage on the Transum website, of course. So you can pause the video at any point to work through the solutions to the puzzles. Some of the solutions are provided in the video, but most are not. It's perfect for festive puzzle enthusiasts aged 9 to 90. I guess. This video provides a fun and educational way to challenge your mind this holiday season. Okay, I've also added a new activity in 6 levels called Quartiles. Now, I wrote shortly after expressing my surprise in last month's podcast about the number of different methods there are for finding quartiles of discrete data. Now, I received a message from the Maths Bazaar on Blue Sky, who informed me that there are actually many more methods than I'd even realised. He very helpfully directed me to an interesting paper titled Quartiles in Elementary Statistics by Eric Langford, and I've put the link to that, as well as all the other things I'm talking about in this podcast, in the newsletter, which is transum.org/newsletter. And I found it a fascinating read. So, inspired by that, I created this new set of online exercises on finding quartiles. And it's now ready for you to use. I've chosen what I consider to be the most common method of all the different methods of finding quartiles, which also happens to be the one used by the textbook and the calculator used by my students. So I refer to this as the popular method. And even though it's the popular method, it's not perfect. For example, if you consider the data set 1, 2, 3, 4, 5, according to this popular method, the median is 3, the mean is 3, and the range is 4. And the lower quartile is 1.5. However, the paper points out that if we duplicate each item in the data set to give 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, well, the median remains the same, as you'd expect. The mean and the range also remain unchanged, as you'd expect. However, calculating the lower quartile using this popular method gives a different result of 2. Surely it should remain the same. So even this method that I'm using and the textbooks recommend, it's not perfect, but there you go. I think it's worth pointing out to students that most of the maths they will encounter is unquestionable and unambiguous, but there are some concepts that can be described in different ways. So just ensure that they're learning the method that's consistent with the course they're following.
You can find Transum Mathematics at www.transum.org.
If you are listening to this podcast on the 1st of December, I can inform you that the first door of the Advent calendar is now unlocked. You won't get a chocolate, but you will be drawn into the Chris Maths collection. Perfect for this time of year, especially the last week of term or the lesson before they break up for the Christmas holiday. Lots of interesting mathematical puzzles, activities, games, all with a Christmas theme. Okay, finally the answer to last month's puzzle, which was...
There are 4 fictional planets orbiting the fictional star Vesperian. Zephyra has 7 moons, Callistris has 10 moons, Draenor has 12 moons. Nymeria has twice as many moons as the mean number of moons for this planetary system. How many moons does Nymeria have?
My method was to let n be the number of moons on Nymeria and then set up an equation involving the mean and the information that's given in the question. I've put that in the newsletter, transum.org/newsletter. The first 5 people to come up with the correct answer of 29 were Marla, Leonard, Shrake, Bardia and Rick. Thanks to everyone who took part, but I will now give you the solution, which wasn't algebraic, which was more intuitive, from Rick. I used an artificial voice on a previous podcast, and he's threatened that he's going to send his real voice, which we're looking forward to, for an answer to a future podcast. But in the meantime, here is a bit of AI pretending to be Rick.
We know the moon mean is half the number of moons for Nymeria. We know the mean is also the number of moons for Nymeria, plus the sum of the moons from the other 3 planets, and that this is divided by 4. Hence, the numerator needs to be double the number of moons for Nymeria. Hence, the number of moons for Nymeria must be equal to the number of moons for the other 3 planets, which is 29.
Okay, that's all for now. Jingle those bells. I'll just leave you with... why can't Santa figure out the area of a rectangle using the formula L times W? Because in the Christmas alphabet, there's no L. I'm really scraping the barrel with these jokes, but anyway, maybe your Year 7 pupils might snigger at them. Bye.
Thank you for downloading and listening to the Transum podcast. You can find the website at www.transum.org, where you're welcome to use all of the activities absolutely free, or jump in with both feet and become a Transum subscriber.